Hello, everyone. Welcome back to a new episode of the Interviews Playlist. Our special guest for today is Renee. Renee, do you want to introduce yourself?
Hi, everyone. Thank you for having me. My name is Renee. I am currently a physicist working for a company called Thermtest in Fredericton, and I did my undergrad at the University of Windsor in biology and physics. And I'm happy to be here to talk today to talk about physics.
Awesome. So the theme of this episode is going to be about your passion for physics. So let's start from how did the passion for physics start in you?
So I originally didn't know very much about physics throughout my high school education. You're taught very much the basics at that level. So my first real introduction to physics was in university, and I was originally in a pre-medical program. So I've always been interested in science. I knew I wanted to be in a scientific field, and pre-med was kind of where I thought I would want to end up. The research aspect interested me, and the different learning opportunities. And then after my first year of physics at the University of Windsor, I spoke with one of my physics professors who was able to kind of explain to me a bit more, what does a physicist do, and what does physics look like beyond your basic Newtonian physics, which is your balls and blocks on ramps and the stuff you learn at an introductory level. So he really introduced me to a lot of the ideas and some of the more advanced topics, such as quantum mechanics, astronomy, astrology, cosmology, and kind of where physics is now as a field, because Newtonian mechanics, of course, are 400 years old. So the field has progressed quite a bit since then, and that really piqued my curiosity. So I ended up speaking with a lot of different academic advisors to get an idea, but at the end of the day, I decided to switch into physics because I really enjoyed the challenge. I enjoyed the mathematical rigor of it, but also how it's able to really fundamentally tackle a lot of the basic questions that we ask about nature. And as someone who is really curious in, well, why do things work the way they do? In nature, things we see in biology, in geology, the earth, all the fields kind of boil down to physics. So for me, by doing physics, I felt like I was really addressing the root question, and then I could take all my interests in the other fields. So I ended up double majoring and keeping the biology side because I was really interested in biology as well. But the physics was like the foundation, and all the other fields helped give perspective to the physics and kind of built on that interest.
Awesome. And what are some aspects in which you believe biology and physics do actually work together?
That's actually a very interesting question, and a really exciting one, in my opinion, because it's funny being on both sides of the fence, I guess. There's a lot of physicists who don't like biology because it's very memorization heavy, and there's a lot of biologists who don't like physics because they don't like the mathematics. So seeing both sides is really fun because I think there's a lot to explore there. And one of the really exciting fields, in my opinion, that's coming up is quantum biology. So it's using going basically one step deeper than biochemistry, and saying, okay, we know there's all these chemical phenomena that occur in the cell, but could there be something deeper on a more fundamental level as to why these things work the way they do? So that's, to me, one very interesting field that is still quite new, and it has been kind of in the background of physicists' minds for a while, but no one has really properly been tackling the question until recently. But obviously there's a big application in medicine. Medical physics is a huge field. that takes a lot of physical concepts and applies it to biology. And then there's a lot more mathematical modeling that takes the mathematical rigor of physics and tries to apply it to biological systems in order to try and explain some of the complexity that we see. So there's really a lot, I think, to explore. And at the end of the day, it's all connected. So it's just one perspective of many. Yeah.
Fantastic. And how did your journey into the world of research begin?
So I started doing research in my first year of my undergrad, and I was actually approached by one of my TAs in chemistry. So it's a bit funny because I ended up doing research in chemistry, which was neither of the two subjects I was studying. But I worked for Dr. Rondeau Gagné at the University of Windsor, who's a materials chemist. But again, I got to explore a lot of the different ways that chemistry relates to physics, chemistry relates to biology. So that was my introduction. And basically, as most undergraduate research experiences go, I began, working with a graduate student, helping him with his research as I learned the field. And then eventually in my fourth year, I was given my own project for my undergraduate thesis, which was a super fantastic experience and really exciting because it showed how I had grown as a researcher and how my supervisor was able to now give me a lot more autonomy and independence. There I was also able to bring a lot of my knowledge from physics and from biology to this now chemistry field and perspective. So that was my introduction, and it was a really, really solid introduction and a really fantastic experience. And then now I've been able to translate that professionally where I work. I now work in the R&D department at the company where I'm at. So it's a company that is designing and making lab instruments for measuring thermal properties in instruments. So now I'm getting to explore like the physics side of the research and development and take what I've learned in my undergrad and use it now as a professional.
Awesome. And what are some key, I would say, key concepts and skills that you have learned from your chemistry-focused research, and how did that kind of help you in your field of interest, which is biology and physics?
Yeah. The biggest takeaway I got from that research experience was just a really solid understanding of the scientific process as a whole. Just getting really familiar. I mean, you do case studies in your undergrad, you look at research, you analyze papers, but it's completely different when you're presented with a problem that you don't know the solution to. And then you have to go and find the papers, which papers are contain the information you're looking for, and then synthesizing that information and designing a procedure for it, and the whole trial and error process that comes from designing an experiment, and the amount of times you're going to fail and like not get the result that you're going to not even be able to get results because it didn't work, and then you have to go back to the drawing board, and the amount of times you go back to the drawing board, and then at the end being able to communicate your results and the importance of your results. And I was lucky enough to even help write grants and stuff. So how do you convince people to fund your research and that your research is important? And then how do you follow up on that and say, okay, here's what we did, here is the progress, presenting at conferences, and ultimately presenting my thesis. So although like subject wise I have kind of changed, and that subject wise it seems like it doesn't necessarily match up, the process itself stays the same no matter what subject you're in. So that was such a fundamental part and such a big takeaway from my undergraduate research experience of this is what it means to be a scientist.
Awesome. And when you first started working on your research project and in a more independent manner, and of course, some of the experiments didn't work, how did basically on the first time and first trial compared to the successive trials, how did your mindset and mentality change moving on?
Yeah. It's definitely disappointing the first time you do something and it doesn't work, because you spend so much time putting it together, and you think you've covered all your bases, and you're like, okay, I'm going to do this, and this is how it's going to work. So it's definitely disappointing, and the more you do it, it's still disappointing, but you're better equipped on what your next step should be, and how to find the information you need to get past that roadblock. So the first time, it's like, I thought I like knew everything I needed to do this test, and it didn't work. What do I do now? By the time it's the 10th time, you're like, okay, I'm just gonna go back and look at papers, look at the references, look at the, keep going down the rabbit hole until I find what I need, talk to other people in my lab, talk to my supervisor. It's really a team effort at the end of the day. Everyone's helping each other. So just having the patience to keep going down the rabbit hole.
Nice. Okay, now let's talk about your internship experiences and your job positions, which you have held so far.
Yeah, in terms of like internships, my undergraduate research was probably my primary internship experience. I was a part of the Outstanding Scholars Program, so that kind of helped financially in terms of an internship. This position that I got, I mean, it was something. I was basically just looking for work and applying everywhere, as many graduates do. And it's been different from like internship positions in the sense that you have a different, there's a different expectation of you in the work environment. People are expecting a certain level of knowledge from you. Whereas of course, when you're starting, there's a lot of learning, but you're expected to have a certain amount of training from your undergraduate courses. So whereas when I'm coming in as what we'll call it an intern or an undergraduate research assistant, you kind of, there's no expectation on what you know. You're fresh out of high school. They're gonna hold your hand through everything. Transitioning to a professional environment, there still is a lot of training, a lot of teaching, and I'm certainly not left on my own. But there is a level of like, okay, you are a professional. We're going to ask you for your input. We're going to, you're going to be more involved in the decision making as opposed to being an intern.
Awesome. And what are some advices you would like to give to students who are interested in doing research and to graduate students who are interested in getting into the world of industry?
For undergraduate students who want to do research, I would say just talk to professors, find a professor that whose personality you enjoy. Because I think that's going to make or break your experience. You could be studying something you're really interested in, but if your supervisor is not compatible with you, it's going to make things a lot more difficult and a lot more frustrating. So finding someone you like is important. And I would arguably say the same thing to graduate students. I have not done graduate school yet. It is something I would like to do in the future, but again, just for me, it's important to have a positive work environment, a supportive work environment, and I would say don't be afraid to explore a broader range out of your field. Grad school, you tend to be very kind of pigeonholed and surrounded by a very particular type of mindset of academics who like diving deep into problems and learning things because they're passionate about it. And you still have those learning opportunities in the field, but it's a different mentality. One, I'll use an example in transitioning from an academic research setting to an industrial research setting that I've found, in an industrial research setting, you're making a product. So you always have to consider the customer in your design, in your research, in your application, all that kind of stuff. That's not something that's so prevalent in academia, because a lot of academia takes many years to enter the industry. So they're kind of exploring for the sake of exploring, just to see what's out there. Whereas in industry, there's a very clear, okay, we need to get this product. We need to consider how is the customer going to use this? How can we improve how the customer is going to use this? So it's a different mentality, and I would urge people leaving graduate school or leaving an academic setting, going into industry, to take that into consideration.
Awesome. Thank you so much for those advices and for sharing your insights about research and industry with us. It was a pleasure having you.
Thank you very much.